Have you ever wondered how Pepsi is made? Today, we're going to reveal one of the most hidden secrets behind the production process. Something almost no one talks about and that you need to know as soon as possible. So make sure to subscribe and leave a like. Let's go.
Phase 1. Water intake, treatment, and standardization. The Pepsi manufacturing process begins with water, which constitutes approximately 90% of the total beverage content. This component, although seemingly simple, requires thorough and rigorous treatment to meet the quality standards established by the company worldwide. Production plants obtain water from various sources. Most extract it from deep underground wells, while others use municipal water systems or nearby natural sources. Regardless of its origin, water is never used in its natural state. Each source has particular characteristics: different mineral concentrations, variations in pH, presence of sediments, and microorganisms. These differences, if not corrected, could generate variations in the final product's flavor. The treatment process begins with basic mechanical filtration that removes large particles and visible sediments. Subsequently, the water passes through multi-layer sand filters that retain finer particles. This initial stage is essential to protect the more sensitive equipment used in later phases. Next, the water passes through activated carbon filters. This porous material has the ability to absorb organic compounds, residual chlorine, and substances that could affect odor or taste. Activated carbon works through a chemical adsorption process, where unwanted molecules are trapped within its microscopic structure. After carbon filtration, the water undergoes a reverse osmosis process. This system uses semi-permeable membranes that allow water molecules to pass through while blocking dissolved salts, heavy metals, and other microscopic contaminants. Reverse osmosis is one of the most effective methods for purifying water, reducing dissolved solids to minimal levels. As an additional microbiological safety measure, the purified water passes through ultraviolet light disinfection systems. This technology uses UVC radiation that destroys the DNA of bacteria, viruses, and other microorganisms without adding chemicals or altering the water's organoleptic properties. Once treatment is completed, the water is stored in sanitary tanks where it is protected from any external contamination. At this stage, laboratory technicians perform continuous analyses to verify multiple parameters: pH, electrical conductivity, hardness, specific mineral content, presence of organic compounds, and microbiological count. Phase 2. Concentrate preparation and ingredient. Dosing with the water already treated, the incorporation of Pepsi concentrate begins, the component that defines the beverage's flavor profile. This concentrate is a complex mixture of extracts, flavorings, essential oils, acids, and colorants carefully formulated. The production of the concentrate is carried out only in authorized plants and under strict security controls. Once produced, it is sent to bottling facilities in sealed and monitored containers. Upon arrival at the plant, it is stored in restricted access areas and transferred to stainless steel tanks designed to preserve its quality. At the same time, sweeteners are prepared. Depending on the market, refined sugar, high fructose corn syrup, or high-intensity sweeteners for sugar-free versions are used. These ingredients are dosed with great precision, as small variations can alter the final flavor. The incorporation of each component is carried out through automated computer-controlled systems. Precision valves and inline sensors ensure exact proportions in every batch. The ingredients are mixed in large tanks equipped with industrial agitators that guarantee uniform distribution. Throughout the process, parameters such as temperature, pH, and density are controlled. The color is also verified using specialized instruments to ensure it remains within established standards before moving on to the next phase. Phase 3. Mixing and flavor control. Once the treated water, concentrate, and sweeteners are combined in the correct proportions, the mixture moves to homogenization tanks. At this stage, the goal is to achieve completely uniform integration, avoiding concentration differences within the liquid. These tanks are equipped with high-efficiency agitators that generate constant and controlled movement, allowing all components to be distributed homogeneously. At this point, the beverage does not yet contain carbon dioxide and is considered a base beverage that must meet strict requirements before advancing. Quality control is exhaustive. Samples are taken from different points in the tank to evaluate the flavor profile. Sweetness levels are analyzed to ensure they remain within established ranges, and acidity is measured, which is essential to balance the final flavor. Color is verified using instruments that compare tone with standardized references, while aroma is evaluated to confirm consistency in characteristic notes. In addition to sensory tests, chemical analyses are conducted to confirm sugar and acid concentrations, as well as the absence of contaminants. If any deviation is detected, precise corrections are applied or, if necessary, the batch is discarded. Once approved, the base beverage is recorded in traceability systems that allow each batch to be identified and ensure consistent flavor in every production. Phase 4. Carbonation with carbon dioxide. Carbonation is one of the key stages in the manufacture of Pepsi and any carbonated beverage. Carbon dioxide is responsible for the bubbles, effervescent texture, and refreshing sensation that characterize the product. The CO2 used is food grade and meets strict purity standards. It can be obtained from different industrial processes or natural sources, but in all cases, it is purified and analyzed to guarantee safety and quality before use. Carbonation is carried out in specialized equipment called carbonators. In these systems, the gas comes into contact with the beverage under controlled pressure and temperature conditions that facilitate its dissolution. Before this step, the base beverage is cooled, generally to temperatures close to 0 to 4 degrees Celsius, since CO2 dissolves better in cold liquids. Inside the carbonator, the gas is injected and dispersed in the liquid, while system pressure forces its integration. The amount of dissolved CO2 is precisely adjusted, as it directly influences flavor, acidity, and freshness perception. Additionally, CO2 forms carbonic acid, which helps preserve the beverage and inhibit microorganism growth. The pressure and temperature sensors control the process in real time to maintain the exact level of carbonation. Once the appropriate value is reached, the beverage is kept cold and pressurized until packaging, preventing gas loss and ensuring a consistent experience in each unit. Phase 5. Container manufacturing and preparation. While the beverage is being produced, the container that will hold it is manufactured and prepared in parallel. The most commonly used formats are PET plastic bottles, returnable glass bottles, and aluminum cans, each with specific preparation processes. PET plastic bottles do not arrive fully formed at the plant. They are received as preforms, small compact plastic tubes that facilitate transport and storage. These preforms are heated in controlled ovens until the material becomes flexible and then placed into metal molds. Through a combination of mechanical stretching and high-pressure air, the plastic expands and takes the final bottle shape. This process enhances material strength, allowing it to withstand internal gas pressure without deforming. After blowing, bottles pass through automatic inspection systems that detect defects such as cracks, deformations, or flaws in the neck and thread. Units that do not meet standards are discarded and recycled. Glass bottles in many markets are returnable. Before reuse, they undergo intensive industrial washing with hot detergents and successive rinses to remove residues, labels, and contaminants. They are then inspected again to ensure cleanliness and integrity. My aluminum cans arrive already formed, but before filling they are rinsed and disinfected to remove particles. Finally, all containers go through a final disinfection stage that guarantees optimal hygienic conditions before filling. Phase 6. Filling, sealing, and labeling. Filling is one of the fastest and most precise stages of the entire production process. Modern packaging lines operate at high speed, allowing thousands of bottles or cans per hour to be filled with a level of accuracy impossible to achieve manually. Empty containers move along conveyor belts that keep them aligned and properly spaced until they reach the fillers. These machines have multiple heads working in parallel, allowing several units to be filled simultaneously. The carbonated beverage is introduced under controlled pressure conditions to prevent carbon dioxide loss and ensure stable, uniform filling. To achieve this, counter pressure systems are used. Before filling, CO2 is injected into the container, equalizing internal pressure and preventing excessive foam formation. Once this condition is reached, the beverage flows precisely until the exact volume is reached, controlled by volume or weight sensors. After filling, containers are immediately sealed. Plastic bottles are closed with screw caps applied with a specific torque. Glass bottles use crimped metal caps, while aluminum cans are sealed through a mechanical double seam that ensures a hermetic closure. After sealing, containers pass through leak detection systems. Finally, Labeling is applied, or existing printing is verified, ensuring all information is correct and legible. Artificial vision cameras inspect each unit and automatically remove any container that does not meet standards. Phase 7. Quality control and distribution. Before products leave the factory, a final and rigorous quality control stage is applied. This step is essential to ensure that only bottles and cans that meet all standards reach the consumer. Each container passes through automatic visual inspection systems. High-resolution cameras examine bottles and cans from different angles, detecting possible defects such as dents, scratches, improperly placed caps, or incorrect labels. Any container with anomalies is immediately removed. Fill levels are also verified using specialized sensors that confirm each unit contains the exact amount of beverage. Additionally, desealing tests are performed to ensure there are no leaks and that carbonation remains intact. Complementarily, random samples from each batch are taken for laboratory analysis. Specialized technicians evaluate flavor, aroma, carbonation, and visual appearance, along with pH measurements, gas levels, and microbiological controls that guarantee product safety. Once approved, the containers are grouped into different packaging formats and placed on pallets through automated systems. Each pallet is identified with batch and production information, allowing full traceability. Finally, the products are ready for temporary storage and subsequent distribution to various points of sale.
So, what did you think? Do you prefer Pepsi or Coca-Cola? Let me know in the comments. Don't forget to subscribe and leave a like.